Hello Math 2 students. The purpose of this video is to help you understand a transformation called a dilation. When you take a polygon in this class and you enlarge it or reduce it, it's called a dilation. And this video will help you understand how dilations work. Make sure you have a pencil and a compass ready to go so that you can write the notes down as we do the example problems. Graph triangle ABC with vertices A at 2, 1, B at 4, 1, and C at 4, -1, and its image after a dilation with a scale factor of K equal to 2. So our first question, what is the center of dilation? Well, on all problems that are on a graph, in this class, the center of dilation will be at 0, 0. What is the scale factor? On this problem, it tells us the scale factor is 2. What are the coordinates of A prime, B prime, and C prime? Before we do that, I'm going to graph the triangle. 2, 1, 4, 1, and 4, -1. Now we can try to find what the coordinates of A prime are. So A is at 2, 1, and A prime after a scale factor of 2 is going to be at 4, 2. For B prime, we have B at 4, 1, and with a scale factor of 2, that puts B prime at 8, 2. And for C prime, we have point C at 4, -1, and with a scale factor of 2, that means C prime will be at 8, -2. So now I'm going to graph the image after a dilation with a scale factor of 2. So I go over 4 and up 2, and that is point A prime. I go over 8 and up 2, and that is point B prime. And I go over 8 and down 2, and that is point C prime. So now if we examine the angles of our triangle, angle A is congruent to angle A prime. Angle B is congruent to angle B prime. And angle C is congruent to angle C prime. So even though our triangle A prime, B prime, and C prime has been enlarged, the angles remain the same. All right, now the sides have to be in the same ratio. So if we take side A prime, B prime, and write it as a fraction with AB on the bottom, A prime, B prime is 4, and AB is 2, which is 2, and that's the scale factor. If we do the same thing with B prime and C prime over BC, B prime C prime is 4 and BC is 2, and so 4 divided by 2 is 2, and again the reason that happens is because the scale factor is 2. Even though we're not going to calculate the distances right now, if we take A prime C prime and put it over AC, when we divide those two lengths, because the scale factor is 2, we know that ratio will be equal to 2. Use a compass and straight edge to construct a dilation of quadrilateral PQRS with center of dilation C and scale factor K equals 3. Now we're going to use the mathematical tool compass and straight edge instead of graph paper in order to dilate this quadrilateral. So to start with, we're going to draw a line that passes through C and S. And because the scale factor is 3, we need to make the distance from C to S and the distance from C to S prime so that the scale factor is 3. So the distance from C to S prime needs to be 3 times as much as the distance from C to S. So the first thing we do is we take our compass and we set it equal to the distance between C and S. Now I'm going to move my pivot point up to S and mark off that distance, and then I'm going to go to where that arc crosses and do the same thing again. And now the distance from C to S is 1 radius of my compass, but the distance from C to S prime is 3 radiuses of my compass. So that is a scale factor of 3, and that is S prime. Now I'm going to do the same thing by drawing a line from C through P and adjusting my compass to the length between C and P. Now I need to make sure that from C to P prime is 3 times as much. So there's 1 compass radius. Here's a second compass radius. And here is a third compass radius. And this is the location of P prime. The distance between C and P prime is 3 compass radiuses, and from C to P is only 1 compass radius, a scale factor of 3. Now I'm going to do the same process going from C through Q. And I'm going to mark off set my compass to the distance from C to Q. And then I'm going to mark off 2 compass radii so that the distance between C and Q prime is 3 times the distance as the distance from C to Q. Now one more time, from C to R, and I set my compass for this distance from C to R, and I go to R and I mark off that distance one more time, and then I go to that arc and I mark off that distance one more time, and now the distance from C to R prime is 3 times the distance from C to R because the scale factor is 3. So now this is going to be an enlargement. So here is segment S prime R prime. Here is segment P prime Q prime. Here's segment R prime Q prime. And here is segment S prime P prime. So quadrilateral P prime, Q prime, R prime, S prime is an enlargement, a dilation by a scale factor of 3. So this is what we know. Angle S has to be congruent to angle S prime. Angle P has to be congruent to angle P prime. Angle Q has to be congruent to angle Q prime. And angle R has to be congruent to angle R prime. Also, these distances form equal ratios. So if we take C over S prime and C over S, that's going to be a fraction that's equal to 3. If we take C over P prime and C over P, C to P prime is 3 times as much as C to P. So that is a ratio that's equal to 3. From C to Q prime over C to Q, that is also 3 times as long. And from C to R prime over C to R, that is also 3 times as long. So our quadrilateral has been enlarged by a scale factor of 3. Use a compass and straight edge to construct a dilation of triangle ABC with center of dilation A and scale factor of k equals 1/2. So now our center of dilation is one of the vertices of the triangle, and our scale factor is a proper fraction, which means this dilation is going to be a reduction. Our image is going to be half the size of the image that we start with. So the first thing I'm going to do is I'm going to try to locate point C prime, and the distance from A to C prime should be half of the distance from A to C. So I'm going to have to construct the perpendicular bisector of segment AC. So you can see that the distance from A to C prime is half of the distance from A to C. Now, I'm going to keep going by constructing the perpendicular bisector of segment AB. That will tell me the location of B prime. So you can see that the distance from A to B prime is half of the distance from A to B. Now, I'm going to construct my image, or draw my image. Each side of triangle A, B prime, C prime has a length that's half of the length of triangle A, B, C. So what we know about this triangle is that angle A is congruent to angle A. We know that angle A, C prime, B prime is congruent to triangle AC, ACB. We know that angle AB prime, C prime is congruent to angle ABC. So all of the angles are congruent, and the sides, if we write them as ratios, AC prime over AC is a ratio equal to 1/2. AB prime over AB is also a ratio of 1/2. And finally, C prime B prime over CB is a ratio of 1/2. Use a compass and straight edge to construct a dilation of triangle LMN with a center of dilation O and a scale factor K equals 2. So now our center of dilation is inside of our triangle. So I'm going to start by drawing 3 rays. And to begin with, I'm going to find point N prime. So the distance from O to N prime needs to be twice the distance from O to N. So I'm going to set my compass from O to N. And then I'm going to go to point N and mark off the spot where N prime is going to be. So you can see the distance from O to N prime is twice the distance from O to M. Now I'm going to do the same thing from O to M and O to L. So now that I have points N prime, M prime, and L prime, this is going to be an enlargement where every side of my pre-image, triangle LMN, is half as long as my image. So the scale factor is 2 because the image, every side is twice as long as the pre-image. Okay, so we know that angle N is congruent to angle N prime, angle L is congruent to angle L prime, angle M is congruent to angle M prime. We know that if we make a ratio like this, OM prime over OM, it will equal 2. And OL prime over OL is a ratio that also equals 2. And ON prime over ON is a ratio that also equals 2.
I hope this video helped you understand how dilations work, how polygons can be enlarged or reduced. I hope that you realize if you have a scale factor that is larger than 1, you will have an enlargement. And if you have a scale factor that's a proper fraction, you will have a reduction. I hope you know how to find a dilation by using your compass and how to find a dilation by using graph paper. Thanks for watching.